So let me just start this. You all have seen the blog, I assume, the challenge here. This is an exercise that I hope you will find challenging, frustrating, and very educational, and even maybe a little bit of fun. The story begins in 2015. I decided that it would be a good idea to learn Lua because, you know, you learn a new language every year or so. So I decided to learn Lua, and I thought, well, you know, I should do it on the iPad because maybe I could learn two things at once that way. So I downloaded a lovely little app called Kodia, made by some very smart people, and I started goofing around with Lua on the iPad. And it turned out to be a very effective graphics platform. You could do really good GUI style graphics with this Kodia platform. Real simple, basic framework for graphics, very similar, Gina, to processing. In fact, they modeled it after processing. They modeled it after that. Very simple idea. So I goofed around with that for a while, and I made myself the traditional lunar lander program where you've got a little lunar lander that you fire the retro rockets and eventually crash onto the lunar surface. And that worked all pretty well. And then it occurred to me, wouldn't it be fun to write a PDP-8 emulator? And so I did. I got an old book out on a PDP-8. Gina, you have it now, Introduction to Programming. And I just wrote a little thing that would emulate a PDP-8. And to my surprise, that turned out to be pretty simple and pretty effective. And even more to my surprise, it executed at a speed that was, within about 1/10 of a PDP-8 speed. Now, this was in 2015 when iPads were a lot slower. And I thought, well, that's interesting. I wonder if I could run any actual PDP-8 software on this. So I did a little hunting around, and I found some old binary versions of paper tapes up on the internet of old programs, and I downloaded them, and I wrote a little C program that would convert them to a reasonable format, and I invented a little way to get them into my emulator, and golly gee, if they didn't actually work. I had to fiddle with it a little bit. There were some hardware issues that weren't quite perfect and interrupt timing things that weren't quite perfect. I had to diagnose a few little problems, but in the end, I got it all working. And there were old programs that I hadn't seen run for 40 years. got them running on there. And I downloaded a few more of these old programs and I got them working. To this point, I now have virtually all of the original PDP-8 software running that would run in a 4K machine. This machine is extremely constrained. It has 4096 words of memory. They are not bytes, they are words. They are 12 bits wide. That was the way that machine worked. And in that, they managed to get a Fortran compiler running. So I'll let you imagine what that might have been like for the poor guys writing that stuff. They also have an assembler working. They've got a symbolic editor working, all using paper tape. The goal of this exercise is to use the tools that would have been used in 1968 by programmers programming a PDP-8. The tools they would have used would have been the machine itself, a teletype, and possibly a high-speed paper tape reader and punch. Nothing else. No discs, no tapes, no nothing. Just that much. So you will be editing using your keyboard, punching paper tape. You'll use a symbolic editor for that. And you will learn the joys of editing on paper tape, which you will find deeply frustrating. And also editing text in a machine that can only hold about 3,000 characters. So don't type too much at a time. Make sure you punch out a buffer and then read in the next buffer and punch that buffer out and read in the next buffer. Keep your batches of text relatively small. You will learn how to run the assembler, and it's a 2-pass assembler. It's actually a 3-pass assembler. The first pass generates the symbol table. The second pass generates the binary punched tape. And the third pass gives you a listing. You tell it which pass you are executing by setting the switches on the front panel. So you're going to have to be comfortable with octal. You're going to have to be comfortable with binary in the programming and the operation of this machine. You're going to need an iPad of reasonable power, something that's at least 3 years old. I imagine will work just fine. You will find that the modern iPads execute at PDP-8 speed, about 150,000 instructions per second, which, you know, you got to think this is actually executing in Lua, an interpreted language, and it's executing PDP-8 coded at about the right rate. You're going to need a keyboard of some kind. I don't know if you've got one of the Apple keyboards or a standard Bluetooth keyboard. They generally work okay. There are certain key mappings that you may have to get used to. For example, on my keyboard, you cannot hit the enter button to enter a line. You have to hit the backspace button to enter a line. So you'll get used to a slightly different key mapping. And there are some keys that we don't use nowadays that we did use back then. And I've got a little key mapping in the README there that I think will help you. If you have a keyboard that is not quite like mine, you might have to change some of the mappings, and that's not actually too hard. The key maps are right at the beginning of the source code. You might have to change the source code a little bit. And with that, I think I've done. The goal again is to compute 100 factorial. You're going to have to do that with integers that are no larger than 2047, excuse me. So you'll have to figure out an array of integers and deal with the multiplication problem and the carry problem and so on. It's not too hard to do. And you'll have to deal with the problem of outputting binary numbers in decimal. That's an interesting problem. Shouldn't be too hard, but you'll have to deal with ASCII code and dealing with the fact that, you know, a 0, you know, the printed 0 is actually an octal 260, and a printed 1 is an octal 261. So you'll have to do all that interesting work. You'll probably have to do a relatively fast multiply and divide subroutines. Remember, this machine can only add. It cannot even subtract. So you have an add instruction, and then in order to subtract, you must do 2's complement arithmetic. Be very careful to read the documents that I've provided. They download with the project. The most important one is called Introduction to Programming. The title there is meaningful. Back in the day, that was what people read if they wanted to learn how to program a computer, because there was no other way to learn how to program a computer. So Introduction to Programming is the name of the book, even though it's very specific to a PDP-8. Read through those chapters. The README that I sent you, that's in the GitHub repository, outlines the contents of those documents and gives you some guidance on which parts you should read and which parts you can skip. Other than that, just have yourself a lot of fun with this. I hope it all works out okay for you. I expect that we'll come back in about a month and we'll review what everybody's done. And it would be interesting if you do a little kibitzing on the blog. So that little blog that I wrote there is just about a page long. You might want to, every once in a while, just throw a couple of hints in there, like help each other out. You know, like I discovered this about the editor, and you can put it in the blog down there. I discovered this about the assembler. There are going to be things that you will discover, and you'll find it frustrating, but something to celebrate when you solve the problems. Are there any questions? Mike asked me to find ways to torture you guys. I thought this was a good one.
Yeah, it does sound like a good one. A question for you, like back in the day when you were doing PDA programming, a project like this, would this be something that a team would work on, or would one person solve a factorial problem like this?
Oh, in the back in the day, programming was done by a single person. This is a machine that you can completely dominate. You know, there are only 4,096 words. So when you become competent in this machine, you know everything there is about this machine. You dominate it entirely. And generally, teams didn't exist back then.
Sorry, you might be talking, but you might be muted.
Yep, that's it. Do you see an issue or foresee an issue by using an emulator for the iPad? For those who don't have an actual physical iPad?
Do you have even an iPad emulator?
Yeah,
You
and
use
Mac.
Xcode to simulate the iPad environment to create an emulator for the PDP-8.
This is like what is it? What Inception, right? We're going to go
Right.
down a dream and then another dream and then another.
Right.
Yeah. Okay. Well, you can try.
Or maybe it would
I'd
run
make
on
no
an M1.
guarantees.
Maybe it could run on an M1.
What's an M1?
The M1 Max, the new processor. Supposedly you can run iPad apps on the M1.
Oh, really? Well, that'll be interesting if you have one.
I don't, but coincidentally, I remember when you presented this emulator back at Smarty Streets in 2015 or 16, and I remember having the thought, boy, I'm glad I'll never have to do that.
The story there is kind of interesting because Apple actually suppressed the ability to share source code out of the Kodia app. So at first I was able to move the source code around, and I got it onto GitHub, very fortunately. And then Apple closed down that avenue, and there was just no way. So I dropped the project. There was nothing more I could do with it. And I lost everything. You know, I had switched iPads. I didn't have it running anymore for 6 years. And then I just happened to be messing around with Kodia the other day, and they've got a new feature, which all of a sudden opens up the gate again. So I got all that source code back in there. It all still worked. I had to fiddle with it a little bit, but so I don't know if Apple's going to close this down again. I don't know how long this is going to be alive, but for the moment, it seems to be working just fine.
Awesome. Well, this is going to be fun. Yeah, we'll figure out all the logistics of iPads and whatnot. But yeah, we should all be able to dedicate a couple hours a week toward this, and it's a little bit scary, but it'll be. I remember doing a little bit of assembler before. It was very eye-opening how computers actually work. So,
Very unforgiving.
yeah, fun stuff.
Do you have any tips before we start on this when we're writing out the assembly for, the inevitable mistakes we make and debugging it?
You are used to typing on a computer. You are used to entering your source code on a screen. Abandon all hope, ye who enter here. Write your code by hand. Type it in very carefully once you have written it by hand. Print it out when you're done. When you need to make corrections, make the corrections on paper. Then edit very carefully from your paper. Some of you will actually obey that first, and some of you will discover why it's necessary, having decided you weren't going to try that at first.
All right.
100 factorial.
100 factorial.
It's definitely
Thanks for that presentation. We'll get started on it.